watching a 20-minute video that really covered a lot of what we're going to do today. And it all has to do with finding surface area by finding out nets, and we're going to be naming different types of figures. So that'll actually be our next lesson. We did end up changing our homework today. We're going to do pages 115, 116, instead of doing the next couple of math sections. But to get us started today, we do a quick review on finding the surface areas. We're going to find the area of a composite figure. Quite frankly, when we're doing nets today, all it really is a composite figure that we're unfolding for the pyramid or the prism. So if you can find the surface area of a complex figure, you should be able to find the surface area of a net. We're going to start with our review on page 99. Okay? We have one problem. I need you to find the surface area. Mr. Channel like this, I would actually do a decomposing on this one. It's easier to do two things. Most of you are going to compose between those three figures, but you should get to the same answer either way. Give you guys about 3 minutes if you can find the surface area, the area of this composite figure. Yeah. I'll put them on the board for you. Yeah, this one. Again, the way I would do this, I would compose it. So I'm going to draw a line here to make it into a big rectangle. So I've got two of them. So for number one, it's just a rectangle. Area equals the base times height. I have a base of 10, a height of 6. So 10 times 6 gives me 60 square yards. For number two, it's also a rectangle. Base times height. This one, they didn't tell me that height, but I know the whole thing is 6. That's 2 and that's 2, so this is also 2. So I have a base of 4 and a height of 2. So area equals 4 times 2, or 8 square yards. And here's where the complex figure composing versus decomposing really comes into play. Speaking of which, we'll give your quiz back at the end of class. A lot of you were able to find the individual areas and you got to put them together, take them apart on the quiz. Is this my answer? No. You minus it. In my case, I have to subtract it. So because I did it decomposing, so 60 minus 8 gives me 2 square yards. Now, if you compose, I'm going to just make an assignment. Most of you probably did it like that. Okay? So I gave you a 6 by 6, so that was 36. 2 by 4, that was 8. 2 by 4, that was 8. 36 plus 16 gave you 52. Did you get the same answer? Yes. Okay. Either way, it's fine, guys. And again, this is one of the things that makes teaching this difficult. There's a lot of different ways to get the right answer. And all of them are right. You have to use what we have taught you to be able to do it. Okay, so the first exercise to me is kind of fun. We do have a definition. So go and get out your marking pen. Okay, the first definition for today: a net is a two-dimensional representation of a three-dimensional figure. One way to think about it is I just took a 3D figure and I just cut around the edges and laid it out. Okay, like I said in the video. So what we're going to do today, we're not actually going to do number 1. Instead, we're going to go straight into number 2, which is there are other nets that form a cube. You need to circle the other 11 cutouts that can form a cube. So I actually gave you a hint. We've got 20 shapes here. 11 of them will form a cube. It is your job to circle all the 11 that will. You can put an X through the ones that won't. So since there's 20 of them for you to go through, we're going to give you guys about 10 minutes. You're going to circle all the nets that would make a cube. You're going to cross out the ones that won't. When you get done, you can have 11 circles on your paper. A cube. That's a great question. I'm supposed to figure that out. The way I do it is I just mentally take the picture and start folding it and see if I fold it, does it become a cube? Or do I end up with parts that overlap each other? Then it's not a cube. Okay? So, here's your chance to practice. See if you can do it. You guys have 10 minutes. So we're going to go through these one by one. Just kind of think about how we're folding it up. So on this first one, what I would do is I take this part and I fold it under. Then this side would now come over to the side, right? that would be the top. This would come around. So that actually forms a full cube. On this one, if I folded it over and then folded it up, these two would actually be in the same spot. So that one's not going to work. This one only has 5 edges. Remember I gave you? 5 faces. On this one, I fold all these center ones around. This one would fold around on the top. That would fold around on the bottom. That one's a good one. Okay, on this one, this would fold under for the bottom. Then that would fold over for the side. That would fold over for the side, over for the other. That would come on the top. So that one is a good one.
Yes, sir.
This one, these are the easiest ones, guys. Because if it's got 4 in a row, those are all 4 going to form the 4 sides. That comes down to the top. That goes up to the bottom. That's another good one. On this one, we're going to have this one fold under. That's going to come around to the side. That one's going to go over to the side. That'll come down to the top. That'll be the back. So that's actually a good one.
Yes, sir.
This one, I fold it around, but then I have 2 on the bottom, nothing on the top. That's not going to work. This one, I could fold around and then under, fold around, around, and around. So that one actually isn't going to work. I don't ever get a top. This one, same kind of problem. I can fold it around. That's going to fold over. That's going to come again. I won't have a bottom. On this one, I can fold it over. That's going to come the side, and that'll become the top. That'll be the top. And then the side, that one actually works. That one actually works. Okay, next one. We've got 4 around. Guys, quiet down. I've got 4 around, 1 on top, 1 on bottom. That's an easy one. Same on this. 4 around, 1 top, 1 bottom. This one, I'm going to go over and to the side, go over, over, and around. That one's not going to work. I'm going to end up, that one's going to be in the same spot as this one. This one will work. That's actually the classic way to do a cube. Most times when you do a net for a cube, that's the one you'll look at. This one actually has 7 faces. Did that possibly make a cube? 7 faces. That's 7. Okay, on this one, I'd fold around, I'd get the top, but then I'm going to do the side again. I won't ever get a bottom. This one, that one will work, because I do the sides and I got 1 top and bottom. This one's not going to work, because I've only got a top and I don't have a bottom.
Only 1 left, so that's bottom.
This one, again, I fold over, around, and up, over, and up. That one should work. That gives us 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Guys, bring it in. Are you guys kind of seeing how you can do this mentally?
Yeah.
That answers our next question. How did you determine which are nets of cubes? I folded them mentally. You see the shape. Guys, you didn't have something written, write it down. Our next one. What do all of the nets for a cube have in common? Consider the number of faces and just have vertices in your explanation. Good. I love the way Asher started us. They all have 6 faces. If we had more or less than 6 faces, we automatically counted them out, right? 6 faces. How many edges are they going to have? Good. How did you get that, Max? I think you're doing a good job. Each edge is going to be more like 2 faces, right? So across the top, I'm going to have 4. On the bottom, I'm going to have 4. And then on each of the sides, I'm going to have 4. So that's 12 edges. And how many vertices? Vertices, that's for 3 edges each.
14.
4.
2.
So 3 of them have to be for 1. So this is 4.
4. 14.
4 on top. 1 down on the bottom. 4 on top, 4 on bottom gives me 8 vertices. One, two, three, 4, 5, 6, 8 places where they'll meet. Those are the vertices. Feet. So this edge, this edge, this edge meet that makes vertices. This edge, this edge, this edge meet that makes vertices. Yeah. Okay, let's go to our next page. We have another definition. So now we've already talked about it. We've done an example of a net. Now let's talk about the next piece. Guys, please stop pattern. The surface area of a polyhedron is the total area of all its two-dimensional faces. So the thing about surface area is the total area covered by the net of the solid. So when I unfold that net, that will tell me what my surface area is. And when I unfold that net, what I'm basically getting is a complex figure. That's why we've done these lessons in the order we did them. So consider the cube you created, which we didn't actually create, but we did all the drawings. How is the area of a face of a cube measured? We're going to give you 2 responses. I want you to explain why the PG is incorrect. So let's talk about this at the table. We'll give you 2 minutes. Hopefully most of you caught it. It's fun talking. One of the students up front, I'll put your name on YouTube for you. Well, like, the teacher's right. That's like, okay. What do you do? What did I say? Okay. The teacher is wrong because she's talking about a 3D figure, so her mind automatically went to volume equals length times width times height. We've been doing for 3D figures. In that case, it's cubic units, right? But what are we doing here? Surface area. Surface area. Surface volume?
No.
No. It's surface area. How do we measure area? Base times height. So is it cubic unit? No. Okay? So she said cubed when it's actually squared. Yeah. Area will always be squared units. We've been saying that since we introduced area, like a month ago. Okay? So to find the surface area, one thing we can do, build a net. And treat it like a complex figure. However, because we are specifically talking about surface area of a cube, what do we know about a cube? Oops. It is a square, yeah? So what do I know about the size, the length and width of a square? They're all the same. So if I'm doing the same, whoa,
Oh.
man, this
What
thing's
is
very
going
long distance. So if I'm doing length and width, but they're the same, they're both the side. Side times side, you can rewrite that as side squared. And how many sides are there on a cube? 6. So for a, and this is specific to a cube, we can say that the surface area equals 6 times the side squared. So let's take a look at this. Back, chair down, you're going to lose the chair. If I do a cube, if I have a side length of 2 on my cube, I can now say my surface area is 6 times 2 squared. 2 squared is what? 2 times 2 is 4. So it's 6 times 4, or 24 square inches. Again, make sure you do this correctly. Okay? If I do a unit cube, what do we know about a unit cube? Side length of a unit cube is what? What is the side length of a unit cube? 1. So I know that my side length is 1. So I can do it 6 times 1 squared. 1 squared is just 1. 6 times 1 equals 6. They don't tell me what the unit is, so it's whatever the unit is. So by definition, a unit cube will have a surface area of 6. Doesn't matter what the units are. It will always be 6. Okay? If I am looking at an actual problem, and this is what I want you guys to go through, but we've got 2 minutes left, so I'm going to have to walk through it with you, most because it's on the video. If I look at a right rectangular prism, they've only given me 3 different measures, haven't they? But I have 6 different figures to find an area for. But what do I know about a right rectangular prism? The opposing sides are the same, correct? If I folded this up, what would this length be? No, this is like this. If I folded this up, what's this length? 4. So this is 4. Okay? And if I folded it all the way around, what's this side?
6.
If I fold it around, this top has come down, right? To take this part right here. So what is this measure? Do I now have enough information to find these areas? Yes. I have 3 figures. Guys, please. I have 3 figures. Figure 1. I'm finding my area. So it's just the length times the width, or base times height. We'll go with base height. So I have a base of 4, a height of 6. So that's going to be 4 times 6, or 24. I can write it here so I have enough room. For number 2, I have a base of 3, a height of 4. You're actually writing this in your books. That's going to give me 12 centimeters squared. For shape 3, I have a base of 3, a height of 6, or a total of 18. Okay, guys, your math here. Is this your homework? Okay, everybody's gone, but I still want to finish the video. The big key on this, so we've done the 3 different areas, 1, 2, and 3, but there are actually 2 of each of those. So we would define the total surface area. I now need to take each of those individual areas and double them. So 2 times 24 is going to give me 48. 2 times 12 will give me 24. 2 times 18 will give me 36. And then I just need to add them all together. So I'm going to 10, 18, 5, 10. So my total surface area So this figure is 108 centimeters squared. Guys, make sure you have the right units. Area will always be in square units. Okay? Another way to look at this, I'm doing a right rectangular prism. We have another surface area formula we can use. 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Which makes sense when you think about it. If I erase these marks and go back to my original prism, this would have had a height of 6. My base would have, my length would have been 3. My width would have been 4. So all I'm doing is each one of these pieces is being multiplied by 2 because there are 2 of each of them. So that's going to explain where that surface area formula comes from. Or you can just draw the net, find the area of each one, double them, get the same answer. So good luck. Again, your homework today is just the next 2 math spaces. You should be at 21. Good luck, guys.